Hey, a domain-specific language, or DSL, is a computer language specialized to a particular application. These can be incredibly diverse, ranging from common tools, such as HTMLs, which are used for web pages, all the way through to more diverse languages, which are only used with one piece of software, much like the one we're using here at Lokad. Today, we're going to find out a little bit more about how they're developed, and also understand why they can be advantageous when compared to some of the more mainstream programming languages. So Johannes, perhaps you could start by just telling us a little bit more about what DSLs actually are and how they actually work.
So DSLs are a specific class of programming languages that, unlike, I would say, the general programming languages that everybody has heard about, probably like the Javas, Python, etc. They are not designed to be solution for everything that you can program on a computer. You know, I would say mainstream programming languages are about giving you the most convenient way, the most productive way, and the most efficient way to basically do everything you can do with the computers, or many computers if you want. But domain-specific programming languages are something else altogether. It's programming, so it comes with code, and it's formal, it's abstract, but it's classes of problems of languages that are designed to solve very specific type of problems. So it's not about doing anything you can do with a computer. It's you pick a type of problem and you solve them. You have, for example, historically, the first domain-specific programming languages were mostly about things like AMPL, a mathematical programming language. They were designed to do literally mathematical programming or such very specific tasks.
So what are the kind of problems you'd be using a domain-specific language for then? What were you using them for in the real world?
So in the real world, I would say historical industrial application would be, for example, to implement, let's say, supercritical components. Let's say, for example, you want to have a piece of software that is going to drive your ABS in your car, anti-braking system, and you want to literally have a proof that this thing is never going to crash. Why? Because if it crashes, your car suddenly doesn't have brake capability anymore. So it's pretty dire, and you would think, oh, let's try to not have something too buggy here. So that's I would say on the embedded side. So that's a class of problems that are relatively simple, but what you would not get from, I would say, regular programming languages is something where you can be almost perfectly sure that it's bug-free. So it's something for very narrow application where it's very interesting to have domain-specific programming languages. Then you have problems like HTMLs for web pages, where it's a programming languages, but you want to have this thing a lot more accessible. I mean, there is a good reason why you can actually learn HTML in primary school. It's because it's very simple. I mean, the basics are literally super accessible to even people that are fairly non-technical. So that's very good, but the trade-off is that HTML basically lets you pretty much control the layout of a web page. It does not let you, for example, take control of a robot or do artificial intelligence or whatnot. No, it's something that is much more constrained, and because it's much more constrained, it can be a lot more simpler as well.
So they're very simple and a bit more constrained. I mean, why are you not using more kind of mainstream programming languages which have kind of more expressivity for kind of these tasks, because they're capable of doing it?
Yes, I mean, for example, just think about what it would mean, for example, in HTML, for the HTML and web pages. It would mean that instead of just having a markup language where you can say title, bigger font size, and body of text, I want to have the text justified and whatnot, simple control, you would have to think, oh, I'm going to control every single pixel on my screen. And that would be what you could get from a super low-level approach. And if you want to be even more low-level, and you say, well, I'm going to directly control of my graphic cards to have super high performance. And that's maybe what, if you're actually building, I would say, a 3D engine for video games, what you would end up doing. But if you just want to do something simple, such as a web page, it would just take an infinite amount of time to do it that way through a 3D video games. It's so much simpler and much more direct to just have to just go through a DSL such as HTML.
Okay, and it's a topic we're very sort of familiar with here at Lokad, given we kind of generated our own DSL. So why was it something that was so interesting to us as kind of a supply chain company?
So the thing that is kind of maddening with supply chain is that problems are so diverse. It's literally, there is no two companies alike. I mean, not exactly alike. You know, they don't have the same applicative landscape. Some companies have one ERP, many have two ERPs for bad reasons. They have a WMS, they have multiple WMS, they have 10 different ERPs because they operate in 10 different countries with different IT landscape. They have the e-commerce platform that came later, which is a separate thing. They have et cetera, et cetera, et cetera. So the problem was, Lokad, we want to do supply chain optimization. And I realized during the early years that literally the classical approach of having a framework that you could configure would just not fly. I mean, situations were just so diverse that we were ending up with a massive amount of customization and of configuration for every single client. And literally, when you start thinking, oh, I have a software, it's completely on the shelf, but it just takes 6 months to do some configuration with the software, is it really, is it really configuration? Are you not like literally reinventing a new piece of software? The reality is, yes, you do. And so we decided to take this angle to the next logical step, which is, okay, if every time we face a situation, it requires a piece of software that is different, what about having something that would support this process to make it very, productive, very fast, very reliable? And actually, it's here comes the idea of having a DSL, domain-specific language.
So if you'd have used a more kind of mainstream programming language, that configuration would take a lot more time, whereas it's kind of having that kind of constrained environment means you can do things a lot quicker.
And that's interesting. I mean, at Lokad, we are using, generic programming languages. I mean, we had been from very start using C#, C#.NET, which is basically the programming stack of Microsoft, and later on we added F# and TypeScript for various purposes. So we are already extensively using, generic programming languages, and I'm very familiar of what you can do with those languages, but we realized during the first years of Lokad that tackling, client requests with this sort of programming languages was just incredibly sluggish and costly. So we needed something that was better. And it was not, the problem was not that we were not familiar with those programming languages, is that we realized that going through them for every single, to suit every single client situation was slightly nightmarish. And by the way, that's also, it's not just Lokad, there is one reason why all those supply chain software solutions end up like gigantic monster, pieces of software. It's because you've tried to put into your software product everything, and then you end up with a software monster. So we decided to say, okay, what if the software product was just a DSL and its capabilities? So something that would be like a super tight core, and then when we go to a client, then we will route our custom implementation, implemented not in C#, but in Envision or on DSL. But the compiler and the environment for Envision, they are actually not implemented in Envision. They're implemented in C# and F# and TypeScript.
Okay, and you mentioned there that obviously supply chains are incredibly diverse. Every client is incredibly different. Does using a DSL introduce any kind of limitations? Does it stop you from actually implementing certain things?
Absolutely, and that's the whole point, as surprising as it might be. You see, for example, one very basic problem that you face, let's you have a large supply chain that you want to optimize, and you end up with a fairly sizable data set. Let's say you have 1 terabyte of data. It's not absolutely huge. You can go into supermarket and buy for something like 100 euros. You will buy a 100 1 terabyte hard drive, which is fairly cheap. So it's a large amount of data, but not gigantic either. Now, the problem is your data set is going to be updated, and every day you want to, let's, for example, do a pass over this data set to take smart supply chain decisions. Let's say, for example, restocking decisions or pricing decisions. Now, the problem is that if you have a generic programming languages, how do you ensure that the computation is going to only take, let's say, less than 60 minutes? It's very hard. I mean, as soon as you have arbitrary loops or arbitrary constructs, it becomes super hard to prove that your execution is going to fit within a specific time frame, which can be a problem if the calculation that you're doing to take certain class of decisions, such as, for example, restocking decisions, need to fit within a tight sequence of execution within your ERP systems, and you really need to have this execution done in 60 minutes. Otherwise, you disrupt literally your entire supply chain because of the calculation that is too long. So that's typically sort of things where generic programming languages cannot give you this sort of guarantees, because precisely you can do everything with it. So it's very hard to get any type of guarantees from those programming languages. But with a DSL that has proper limitation in place, it is. Also, there is other angles that are more mundane, such as it's actually very hard to offer a programming environment that is completely secure with a generic programming environment, with the generic programming languages. You see, as soon as you start to say, I can write any Java program or any Python program or any C# program, those mainstay programming languages, you open yourself to enter classes of security vulnerabilities. It's, again, if you can do anything with a computer, you can do things that are relatively dangerous, I would say, from a security perspective, IT security perspective. So again, having a DSL means that there are entire classes of things that are just not even accessible to you, such as playing with the OS, and thus it removes entire classes of problems that are not even your concern, actually, if all you care about is supply chain optimization.
Yeah, and that's what we kind of spoke about on our kind of security episode.
Yes.
Let's look at maybe sort of the development of a DSL. I mean, how long does it actually take to kind of develop one of these languages, and kind of your position? How long did it take to develop in Vision?
That's awful. It literally takes a decade, which is kind of insane. So when you're a startup, you say, move fast and break things. Let's have like a minimal viable product that you can sell within 6 months, and bam, you start crafting your own DSL, and it's like literally a process of a decade, which is kind of insane and not exactly super aligned with startup values of changing the world in 6 months. So nevertheless, we decided to go down that path. It's literally maybe not a decade, but it's certainly a multi-year effort. The key challenge is that you really have to rethink at the core the problems that you're solving. What are the fundamental aspect of the problems, and what should be the logical primitives that needs to be accessible to your mind, to solve those problems with computers. It's even worse than just inventing new words. It's inventing logical primitives, way of connecting concepts, so that you can in the end frame enter classes of solution into this language to get solution generated in ways that are fully automated thanks to computers. But you're literally thinking about the programming language itself, its syntax, the type of operators you have, which is, and you really want to have those things completely aligned with the problem that you're trying to solve.
So if you were a sort of a startup starting out now, would you recommend setting out on that path and developing this language, which can be incredibly time consuming, incredibly difficult to do? Or would you more recommend sort of staying put and working with more kind of mainstream programming languages?
I mean, that's obviously, first, crafting your DSL is not something that you will use as a substitute for mainstream programming languages. So if you're a software company, your DSL, when you want to create these new languages, a way to solve entire class of problems as we do for supply chain, I mean, first you will need a compiler and a way to and a runtime to execute, this programs written in these programming languages, and this compiler will be written with a regular programming language. So first, it's not because you go to a DSL path that you will not need software engineers. Quite the contrary, you will even need even more software engineers. But considering the question for startups, I think it's interesting because precisely there is, I believe that the DSL path has been, is so ambitious that it has been, I would say, significantly underexploited. And I see many companies, software companies, startups, that try to address problems the classical way because they are in a hurry, and they end up with, I would say, slightly, unsatisfying products. I mean, that's obviously, who am I to say that? But when I look at the type of products that they are delivering to the market, I say, well, it's interesting, but it's you're heading straight toward becoming, a big piece of enterprise software, which is not exactly where you want to go. I mean, one example would be, for example, for what I call MOMS, multi-channel order management system. There is another wave of software products that went down that path, and the bigger ones now are starting to look like pretty much like ERPs on their own, with literally hundreds of screens, thousands of options, and it literally takes months to properly set them up. And they are not necessarily ending up in a place that is so much better than the ERPs that was the starting point of differentiating themselves from the ERPs to have products that were leaner, faster to deploy, etc., etc. I mean, 10 years down the road, you end up with something that is incredibly similar to an ERP, and maybe that's typically sort of problems where using a DSL would have made a difference to end up with something that was much more drastically different and much leaner, much, I would say, powerful in so many ways.
So it's kind of a mixed message we're kind of giving here, because we're sort of saying that with a DSL, you're very much constrained, you're going to have years of headaches, but eventually when you get to the end, you'll be in a fairly good position. Whereas if you go down the route of using a more mainstream programming language, you might have more rapid growth, but then you might end up with an unmanageable beast.
Yes, and you see, it's interesting because, for example, one of the first super successful DSL was actually SQL, the query language for databases. I mean, nowadays, every single vendor is database vendors. I mean, the database vendors are very large. I mean, at least the popular ones. So it's huge markets. And it's interesting because if you're a database vendor, what you're actually selling is a DSL. It's the only way you can meaningfully interact with a database is by making queries to the database, and those queries are written in a domain-specific programming language, the DSL. So it's very interesting to see that when DSLs becomes so, I would say, incredibly successful, people even forget about the fact that it was a DSL in the first place. It just become a thing of the applicative landscape, just like HTML. I mean, people would say web pages, they would not think DSL. It has become so prevalent that people even forget that it was like a DSL effort initially, and then it took so much momentum that it becomes like a thing of its own, an industry of its own. But I believe that there is a lot of potential to do that in many other industries. and obviously with Lokad for supply chain and their quantitative optimization.
Okay, so to conclude, maybe supply chain industry, we've done it. What are the other industries that maybe you think are very useful and could work well with a DSL?
I mean, probably you see, marketing is one of them. Right now, I see a lot of companies that are struggling with super complex software solution, and they are nowhere near, I would say, powerful enough. And then you end up with people doing a lot of very cool stuff with Python, but it's a nightmare to maintain that and to pass that into production. So there is plenty of areas for DSL there. Human resources as well. It's human resources is always something that is super ad hoc because it reflects the culture of the company. So it's very hard to have something that is like one size fits all, this sort of problems. So again, I'm pretty sure that DSLs have tons to bring in this area, but literally, I believe that DSLs have tons of things to bring in literally every single industries. Although the way it rolls out can be completely different from one, I would say, one problem to the next. And that's kind of the beauty of it as well.
Okay, well, we're going to have to leave it there, but thanks for your time today.
Thanks.
So that's everything for today. Thanks very much for tuning in, and we'll see you again next time. Bye for now.